Laurence, Kirk, thank you, coming down from Oxford. Laurence used to work for banks, but then he left to explore opportunities around Ethereum. His own consultancy is called Extrapy, extrapy.io. So he's helping, he's advising people on possibilities around developing Ethereum-based solutions. And he's here tonight to give all of us a presentation, everything we need to know from a beginner's perspective. So over to Laurence.
Hi. Thank you. Hello, can you hear me at the back? Yeah, okay. So thank you everybody for coming. Thank you for avoiding the lure of the Hyperledger talk as well and staying with us. Right, what I want to talk about tonight, I'm going to start off talking about the components of blockchain technology, because I don't know how much you all know about blockchain, what sort of level you're at, but that's a useful introduction. And if you want to understand Ethereum, you have to understand, and if you want to understand why Ethereum is special, you need to understand what special parts of that technology make Ethereum special. I'll then go on to looking at Ethereum itself and how to write distributed applications. Unfortunately, I can't do a demo of the cryptocurrency tonight. We don't have Wi-Fi. I don't have my laptop talking to the projector, so I'll just have to talk about that. We'll have to do that another time. Finally, I'll talk about the implications that Ethereum will bring to the web and businesses and society. So let's start off. Just a quick description of Ethereum. It's a decentralized platform that runs smart contracts, and they run exactly as programmed. That's all you need to know about it at this stage. If you're used to Bitcoin, which I think most of you are, it's useful to think how it differs from Bitcoin. So it's much more general than Bitcoin. It's not just a currency, it's a general platform for writing applications. As with Bitcoin, the system consists of nodes, but each node has a virtual machine that runs smart contracts. And transactions are sent to these nodes and call functions on the smart contracts. If you go to sleep during this talk and forget everything that I've said, please just remember two things. One, there's no central authority, and the second thing, everything is all about trust. That's the kind of the problem we're aiming to solve. So having said that, if you want to fall asleep, go ahead, but please don't snore. Okay. Just to say a little bit about this issue of trust. We have all these systems, institutions in place, all societies do, to provide trust between individuals and companies. One of the problems that the blockchain is trying to solve is to get around that, to reduce the amount of trust that people need before they can interact with each other. The quote there from Gavin Wood, who is one of the inventors of Ethereum. So there are three components that I'd like to talk about initially that make Ethereum special. So the first one is peer-to-peer networking. Second, the blockchain data structure itself and the mechanism that it uses. And the third, cryptography. Now these three components are components of blockchain in general. They're not special to Ethereum, but it's useful to understand what properties these have, because then you'll better understand how Ethereum is special. So if you look at peer-to-peer networks, they're decentralized. That's my main thing to remember. If you've forgotten, there's no central authority. That means they're censorship-proof. If a government is doing a peer-to-peer network, it's very, very difficult for it to stop you doing that. And that also means it's highly reliable. If one of the nodes on the network fails for whatever reason, it doesn't matter. Transactions, messages can still pass around the network. And some examples of where this is used at the moment, or has been used, Napster, BitTorrent, Spotify. I think we're all probably fairly familiar with peer-to-peer networks. The blockchain itself, the data structure, you can think of it as a public ledger. All transactions that happen in the system are seen by everybody. And the state of the system at any point is arrived at by consensus. So this is true for Bitcoin, for any cryptocurrency. It's true for Ethereum. Thirdly, we're relying on cryptography. Public-private key cryptography, we all use this every day for our credit cards, whatever. But this means that any transactions we do are tamper-proof. And the origin of a transaction can be verified. We can say that this transaction came from this account because that account has a private key. We know it came from them. Obviously, there is pseudonymity, so we don't know who that account might belong to in the real world, but we can be sure that it came from a particular account. The last part there was just to, in case anybody wants to know how accounts are created in Ethereum. That was one of the questions I wanted to know about Bitcoin, is how do you create an account? How do you get your account number? They're created at random, but the numbers are so big that it just doesn't matter, and there's no chance of a clash. Similarly with Ethereum, they are, and they throw away some of the bits, and you get an account address on Ethereum. Okay. So, in summary, the peer-to-peer network means we've got a censorship-resistant platform to work with. The blockchain itself means we have transparency. We can verify the transactions are valid. The state of the system is arrived at by consensus. Cryptography means that we have tamper-proof transactions. If you bring those features together, that increases the trust that people can have in the system. We can have confidence in interacting with people across a blockchain system without needing some central authority to provide that trust. For example, if you think about Bitcoin, if you wanted to send somebody some money, if you go out into the street and give somebody some cash, say, please give it to my friend, well, you never see it again. But you rely on that. You're happy for, say, Bitcoin to do that. The Bitcoin system can pass your value around without you being concerned who that's going through. You do have trust in that system. Okay. Now, Ethereum is different from Bitcoin, as I said. It's more general. And it allows you to write distributed applications. The name that people have come up with for these applications are smart contracts, or these are small pieces of code, and they live on the Ethereum blockchain. They have a particular address on the blockchain so that you can reference them, and they have what I call here a balance, so they can own their own currency. They can typically they receive transactions, but they can also send them. And they are activated when they receive a transaction. They can be killed to some extent, but typically with the blockchain, if something's on the blockchain, it's on there for good. So the Ethereum virtual machine runs a Turing-complete language. There's a number of languages you can use. I'll explain more about the fees later on. And it's useful to remember that when you're running a smart contract, you can run that on your local copy of the blockchain. So every client who's on the Ethereum system has their own copy of the blockchain. They receive all the transactions, they update their own version of the blockchain. They can, when they receive a transaction, and they do, they will update their own copy. Now, if you need to update the blockchain, you need to obviously pass that around. That transaction needs to go to everybody so they can update their own copies. If you only need to read a value from the blockchain, then you don't need to send a transaction around. So you can just read a value from your own blockchain without using a transaction. And we'll see how that's important later on. So if you look at an Ethereum node, typically this has a virtual machine. It will have a number of smart contracts in it. A transaction will come in and call a function on one of these smart contracts, and that will update the state of the blockchain that you have. That transaction is distributed around the network and updates. It calls the same function on every node, which updates their own personal contract. If you like to imagine all of you tonight represented a node on the Ethereum network. If you imagine that you all had your laptop, that would be like the virtual machine. And you are being given a transaction, perhaps some instruction about what to do, and you're updating perhaps a spreadsheet on your laptop. That is sort of a good analogy, I think, for understanding how the Ethereum system works. And when I first heard this, I thought this is incredibly wasteful, because I come from a background of low latency systems, and it seemed to me ridiculous that every node on the network would be doing exactly the same thing, coming up with the same result. And it is ridiculous in a sense. It's extremely inefficient. you are doing exactly the same thing. The point is that you're building a consensus. So at every node, they can check what the transaction is, they can verify it, they can build their blockchain, and there is a consensus built across the whole system about what the state of the system is. And that's what makes Ethereum special, and that's why this is useful. If you want to write smart contracts, there are a number of languages you can use. The most popular one is called Solidity, and that looks a little bit like JavaScript. This second most popular, Serpent, is Python-like. Mutan is not under development anymore. I think it's pretty much dead. And the Lisp-like one, I think it's still used occasionally. If you're a Lisp fan, you like brackets, then good luck with that. Basically, all of these languages, there's a compiler for them, and they're compiled into bytecode, which then is run on the virtual machine, on the Ethereum virtual machine on each node. To give you an example of how this might work, you can imagine a voting application. Imagine you have some people who want to vote on some proposal. Each person would have an account in Ethereum. They would call a function on the smart contract to register their vote. That would update a value in the smart contract containing the count of votes that any particular proposal had. So they just send each transaction in, it goes around the network, and each node on the network updates their own copy of the blockchain with the number of votes cast. If you want to know, and the smart contract can then react after a certain time and say who the winner is. If you want to know what that looks like, this is Solidity code. This is given as an example in a tutorial. I'll try and explain some what it is. This isn't the whole amount of the code, but over here, this is the storage. This is the variables that you have in memory. So this is containing the information that you're going to update. The rest of it here, we have some functions you can run. This function here has the same name as the contract, and that is a constructor. If you're familiar with object-oriented programs, you will know what constructors are. This function runs when the contract is deployed, and so sets up the default values for the contract. The function vote here is the one we're interested in. So you would send a transaction to this contract, specifying which proposal you wanted to vote for, and it would record the details of your vote in the structures over here, in the storage, and may send back some values just to say you've done that. At the end of it, you can check which is the winning proposal. Now, what I was saying before, there's the idea that you can send transactions, or you could just look for some data in your local copy of the blockchain. This function here is marked as constant. That means that it's not going to update the blockchain in any way. Therefore, you can just read the values here from your local blockchain. You don't need to process around the network. You don't need a consensus for that. So you can just read the winning proposal from there. Now, one problem that you may have thought of about this is what happens if you're a malicious person, you write a malicious smart contract, you put it onto the blockchain, it has a function in there which has an infinite loop in it. What would happen then is people would call that function, their virtual machine would just go into an infinite loop, stop, or perhaps it would, you would try to send it a huge amount of storage, or you would try to allocate a huge amount of memory. You'd be doing a denial of service attack effectively on the whole network. You could just stop the whole thing. The way to get around this is by the use of what they call gas. So every operation that runs in the virtual machine uses a certain amount of gas. This is like a transaction fee, in effect. So when you send a transaction to Ethereum, you say up front, I'm going to pay this amount as a transaction fee. I'm prepared to pay this amount of gas. when the transaction runs in the virtual machine, each time an instruction, each time an operation is executed, it costs a certain amount of gas, and each instruction has a different price. That takes that out of the gas that you've paid up front. If the amount of gas you've paid, the virtual machine stops that function, rolls it back, and that effectively would stop any problems with an infinite loop. Obviously, there is a limit to the amount of gas that you're allowed to supply up front. It used to be 1 million pi. It's gone up a little bit now, slightly more in ether, anyway. But yeah, it's a certain amount. So you have to be prepared to make this transaction cost up front when you run a transaction. I was hoping we could do a demo of creating a cryptocurrency for us tonight. Unfortunately, we don't have Wi-Fi, and my laptop wouldn't talk to the projector properly, so we can't do it. It's incredibly simple. So you're used to Bitcoin. That's the currency that's been, that you know. In Ethereum, you can create that in just a few lines of code. It just takes a few minutes to deploy that. It is a very simple thing. It's actually, if you go to the Ethereum org website, look at their tutorials, it's the first tutorial they have, is to create a cryptocurrency. It's a lot of fun. I would encourage you all to do it. You can make yourself millionaires in your own little coin overnight. All you have to do then is get somebody else to buy them. If you want to write some code, there are a number of IDEs. It's still there's still a lot of development going on in this area. This one is called EtherCamp. A little bit unfocused, unfortunately. But it's quite well-developed IDE. You can write, it acts as a compiler. It also has some support for JavaScript, so you can write your front end as well. On the right-hand side there, it has its own little sort of dummy blockchain, so you can write some code, you can deploy it, you can look at what it's doing on the blockchain. It's not bad. It runs on Cloud9, so it's its own virtual machine. At the moment, it is free. They did plan originally to get you to pay for it. I think they've changed their mind. They're going to keep it free for the time being. So if you're interested, go to ether.camp and try that one out. It's quite functional. Another one is Truffle, which has a good testing framework. Works with Mocha and Chai. It's generally a command line thing, so you need your own IDE to start using it. The one that comes from the Ethereum organization is called Mix. To say that I have a love-hate relationship with it is more of a hate-hate relationship, really. I get endless problems trying to get this thing to compile and work nicely. It's also rather counterintuitive in the way that you create your applications and test them, but it's worth trying. Again, on the left-hand side there, you see you have some contract. On the right-hand side, it has its own little dummy blockchain that you can deploy to. Once you've finished testing it on that, you can then try deploying it to the real world. The one I was hoping to demonstrate, but I can't because we don't have internet access, is there's an online Solidity compiler. It's browser-based. You just type in your Solidity code, it compiles it, it gives you bytecode, and you can just copy and paste that into your own node in Ethereum. That's the one that I use. It's very basic, but it means that it doesn't go wrong. Yeah, I would recommend looking at that. It's very good. It just works. That's the online Solidity compiler. Yeah. So it's browser-based, and it just works fine. It has its own little browser-based virtual machine that you can use. You can then connect to a running node on Ethereum and deploy from there into the running node. Yeah. So Ethereum have a larger vision. Rather than just being smart contracts, they have a couple of other areas they're looking at. Neither of these are complete yet. The first one is Swarm. which is there for storing data, and then Whisper is for messaging. One of the problems with Ethereum that you'll find is, as I mentioned, you have this concept of gas. So everything you want to do, you've got to pay for up front. If you want to store anything, it's extremely expensive. Generally speaking, if you want to write an Ethereum application, don't store, or store as little as possible on the blockchain. Store it, just use that for where you need to have it on the blockchain for whatever special purpose the blockchain has, but keep things off blockchain if possible. A good technology stack that people have come up with is to use Ethereum, and there's a platform called IPFS. Swarm is another thing that's similar to IPFS, and it's a distributed storage system. So this is under development at the moment. As I say, it's not complete, but it means that you can store vast amounts of data cheaply, whereas you can't really do that storing it on the Ethereum blockchain, because that would just cost you a huge amount of gas. And you can understand why that is, because if you try to upload a movie into Ethereum, then every node on the network would have to then download that movie. Again, it's a denial of service attack, effectively, you're doing. Whisper is a messaging system. It's meant to be anonymous and secure, but again, it's not complete yet. Watch your space. So why would you think about using Ethereum? It's great for uptime. You have a peer-to-peer network. If a node goes down, it just doesn't matter. You can just pretty much guarantee that your application will always be there. You store it on the blockchain is not going to go away. If a government doesn't like what you've done, well, what can they do about it? It's pretty much always going to be there. Conversely, be careful what you put on the blockchain, because it's always going to be there. The security is good. It's as good as the security you're going to be using for your credit card transactions. If quantum computing comes along, that could be problematic. Personally, I'm going to be more worried about my bank than I am about Ethereum if that happens. But people have been looking at this, and there are ways around this. Once you've deployed your application to Ethereum, it's effectively free to run. So, I mean, a lot of people, I don't know about you, but a lot of people may use something like Amazon to host their application, and they will pay a fee for using their cloud service. They pay a monthly fee or whatever. If you use Ethereum, once you've deployed to the blockchain, that's it. You don't pay another fee to keep it there. It's there, that's it. Your users of your application may pay a fee because they're paying a transaction fee, but that's good for your business because that means you're only having to pay that fee when your application is being used. So it's a great business model from us. Transparency, if you're wondering whether you can trust a particular application, well, go and look at the code. People are encouraged when they deploy Ethereum applications to put the code, open source the code so that people can see what it is. If they don't do that, well, it makes it more difficult. But you can go to the blockchain, you can look at the bytecode, you can find someone technical who will be able to go through that and say, yes, this does X, Y, Z. So it should give you confidence in what the application is doing. At the moment, we tend to trust Facebook or Amazon or whoever for no particular reason, just because we do trust them. With Ethereum, we can actually go and see what is actually running. And we can know that it hasn't been hacked. You could get the source code, compile it, check it against the bytecode on the blockchain. It's good for micropayments. So the currency that Ethereum uses, Ether, can be split down to the smallest denomination is called a Wei, and that's there are 10 to the 18 of those in one Ether. So if you want to buy a significantly small fraction of something, you can do that. Similar to Bitcoin, if that makes sense. DAOs and consensus applications, I'll talk about in a moment. And yeah, identity and reputation services I'll come on to as well. I'm not someone who believes that this is going to solve all the world's problems. It has limitations. So generally the virtual machine is slow. Your smart contract is going to run slowly. It's not. If you're thinking about, say, training machine learning on it, well, don't. It's, you're wasting your time. You do straightforward things, it's not going to be fast. That's not why you're using Ethereum. As I said, storage is expensive. Use IPFS instead. Nobody's asked me what IPFS is. It stands for Interplanetary File System. It's a decentralized storage system. Again, once you put something on there, it's there for good, so be careful what you put on there. But I would encourage you all to look at that as well. If you want to host a website on that, it's a good way of doing it as well. Scalability is an issue. We've seen scalability problems with Bitcoin. People are talking about scalability with Ethereum. It is something that is actively being looked at. There is generally a trade-off. If you want a decentralized blockchain, there you do have a trade-off with performance. So the way around this is you can create your own blockchains. You could have a private blockchain that only a few people use, that have a limited number of transactions, but then you lose the public aspect. But scalability is an issue. You need to think about that. And private blockchains, yeah, they're going to proliferate. We've seen banks are getting together in consortiums. They're jumping on this because it helps with their clearance, but they're likely just to use their blockchains for their own purposes. They're not going to let just anybody join in, and they're going to limit the amount of transactions on there. So what are implications of it? As I said before, remember, there is no central authority. We don't need some third-party intermediary to stand between me and someone that I'm trying to buy something from to show that I can trust them. This is quite a significant thing. We can resolve, we can process payments, we can resolve things by the system itself rather than having to have somebody in between. The great word disintermediation is going to be quite powerful, I think, this idea. As I say, there's going to be people who are going to be worried about this. It's going to be middlemen. So if you use Kickstarter to set up your business, they take a fee. I think at least 5%, it could be more. Some people have quoted 20%, whatever. If you want to do crowdfund your startup on Ethereum, you can do that. It's extremely simple to write. It's one of the tutorials on Ethereum is how to do this. You can write your own crowdfunding smart contract, get it onto the blockchain, Ethereum blockchain. It's there. People can start to use it. They will pay a fraction of a cent for each transaction they want to do, but it's effectively free. You don't pay anybody a fee. The smart contract itself will do everything that Kickstarter can do. So we don't need Kickstarter. I was looking at an election system, a voting system at the end of last year. I saw this thing called OpenVote. They charge $500. I don't need to do that now. I can write my own thing. I can write a smart contract to do that. Effectively, it's free. Uber, Amazon, we can replace all of these people. Any kind of agency, we can replace those kind of people. I loathe recruitment agencies. I've been contracting in IT, and I've had to go through them. I absolutely loathe them. It gives me a great deal of pleasure and hope that one day I won't have to do that. Estate agents, perhaps we'll be able to replace those. People generally don't like them. We shall see. Meetup. I have to pay a fee to Meetup to run the Oxford Ethereum group. Why should I have to do that? I could do all of the functionality from that on an Ethereum smart contract. Because of transparency, because everybody can see transactions, if you're involved in corruption, this is probably going to be a bad time for you. For this reason, it's great for voting systems or for systems that you can use to prove your ownership of things. So if you can reduce the amount of corruption in the world, that would be good. Typically, just any centralized business and organization, they could be impacted by Ethereum. Now, like I say, I don't want to be too idealistic about this. This is going to take time. It will happen in stages, but it could be very powerful, I believe. Something that has got a lot of news, going to be in the news a lot lately, decentralized autonomous organizations, DAOs. So they're a very interesting idea, and they come about because we have these features of the blockchain that allow us to run smart contracts, allow us to do a particular kind of business. The idea for a DAO is that your business will be run according to rules that are specified in a smart contract. So instead of having board members who will decide how to run your business, how to, say, go for crowdfunding, how to distribute dividends, you will have a contract living on the Ethereum blockchain that does it. Additionally, the DAO will probably have some sort of property, maybe some currency or something of value that it owns, that then will be used. Anybody can see, because of the transparency of this and the smart contracts, any outsider can see how this company is being run. If you're involved with any companies at the moment, do you go and look at their constitutions? Do you check those out? Do you know that they're being followed? If you have a on the blockchain, on the Ethereum blockchain, you can see exactly what they're going to do. There'll be no surprises. There are quite clever ways that the DAO can make decisions. It may be that it will ask for voting amongst shareholders, or it may use prediction markets to do that. An example, if you want sort of an easy example for this, I was thinking of was if you had a company that, say, wanted to set up do insurance. So you could start up your insurance smart contract. You could get shareholders to send you to buy shares in your DAO, and that would give your DAO a large capital. Then the smart contract may say that it's going to insure its clients against, say, bad weather. The clients would pay a premium to the contract, and the contract would keep that. Again, no people are involved here. It's just calling a function on the contract. The contracts could get information from outside about the weather. If it rains on your parade, then you can be compensated by the contract itself. The contract could make the payout to the person. Again, no people have been involved in any of this. Any profit that the contract makes, it could then, every 6 months, pay as dividends to its shareholders. These are very interesting from all sorts of perspectives. At the moment, the legality of these is very nebulous. So, if I set up a DAO today, and the British government decides they want me to pay some tax for that, well, good luck to them. For a start, how they're going to know that I did it? I can set it up from an account. They don't know who that account belongs to. Generally, if you set up a DAO on the Ethereum blockchain, what legal jurisdiction does that fall under? Which country did that originate from, really? The transaction might start in a particular country, but is that where the DAO is based? Who knows? If the government, or any government, doesn't like what your DAO is doing, what are they going to do about it? It's there on the blockchain. It will last for as long as the blockchain does. It will continue to function for as long as the blockchain does. These are very interesting, very powerful ideas. And at some point, these will be tested in law, I guess. It will be very interesting to see what happens. When that happens, it will be interesting to see how governments and lawyers try to do something about these things. The news that you'll probably be aware of and where you may have heard of DAOs is because of this. The DAO, or the DAO Hub, as people called it, has just finished its crowdfunding, I think, a couple of days ago. It is the largest largest crowdfunding in history. I got these stats yesterday. It said it had raised $132 million, which is pretty good going, I think. There's a lot of interest in this. What it's going to do with that money now is going to be interesting. The idea is that the shareholders, the people who funded this, who have bought DAO tokens, will then be able to vote on how they want that money to be distributed, to be used for funding other projects and there will be a consensus built about how the money will be invested. But there has been a call for a moratorium about this, because some people have said that there are security issues. So they've said, please don't use this at the moment. There are going to be problems. This is all new technology, so we shouldn't really be surprised. One of the problems I think people have seen is that you could create this massive crowd fund, you can get all this money into your DAO, and then get all your friends to come in to vote so that you all spend that money on yourselves, or throw a big party, or put it into a particular fund that you own. Yeah. There are lots of issues around this that need to be resolved. So do watch this space over the next few days and weeks. This is going to be very interesting, what happens to this $132 million. Another area that Ethereum is going to be very useful for, governance. So it's great for if you're looking for a voting system, because of the transparency, because everybody can see what's happened. It's going to be very difficult for people to get involved with corruption. The actual mechanisms of voting about who wins the election will be written into the smart contract, so the people who vote can then be confident in how that voting will be done. These are some theories and ideas that people have come up with. I won't go into any of them in particular, but again, there's a lot of possibilities that could be developed around democracy and bringing together people into organisations simply and allowing them to vote on proposals. Certainly, if you're interested in creating any kind of organisations, it's worth looking at. The question you should be asking when you see some new technology, is this a lot of hype? You've probably seen this curve before. I think at the moment we're probably heading on this sort of area, coming towards the peak of this. I've spoken to people who've said that this is a larger peak than they've seen before, so they're expecting the trough to be larger too. I'm waiting for it to come through to the other side. It's going to be good when we get there, but wait and see. Yes, there's a lot of hype about, but yes, this has a lot of potential. So it's not all hype. If you want to look at who people are using Ethereum, this is just a quick breakdown. A lot of people in infrastructure at the moment, a lot of applications in infrastructure, but there's just a wide range of applications at the moment. So as you would expect, currencies, but also we've got gaming there, financial services, and banks are really all over this and throwing a lot of money at this at the moment. These are some companies that are using Ethereum at the moment. I think you had a talk a couple of weeks ago from Colony, so I won't talk about them. Augur, I like. Prediction markets are interesting. Go and have a look at them. They're a great idea. Augur are doing that on the blockchain. Provenance have been held up as a great use of Ethereum. They are using the blockchain to provide transparency about supply chains. Maker, an autonomous bank, a market maker. Yujo Music, I like Yujo because this is quite a different idea to a lot of the applications. A lot of applications at the moment are in financial area. So Yujo are looking at the artistic side of things. They have looking at using the blockchain to streamline royalty payments to artists. And Imogen Heap was working with them. So that's good to see. These are some more. I won't go into them in any particular. Transactive grid, they're looking at allowing you to sell your energy to your neighbours or whoever if you have solar panels. Autonomous are a good company. If you want to set up your company very simply, you can just go to them. They'll put it on a blockchain. IoT and Ethereum is a good mix. You may well have heard of Slockit. They are really leading the field in a lot of ways. They're doing a lot of, they're driving a lot of the publicity behind Ethereum. They're driving a lot of the publicity behind the DAO that's just been crowdfunded. Their idea is that their IoT device is a lock, and then you can use that to lock, say, an apartment, and then rent out that apartment, and people will be allowed access to via the smart contracts, so they will access it via their account. But the possibilities are much wider than that. Generally, the IoT area is great for the blockchain. If you have an IoT device and you want it to have some rules, it will have to have an internet connection, obviously. So why not give it a smart contract on the blockchain? You could imagine this situation where you have, say, a solar panel that is generating some energy. It has its own smart contract. It sells its energy to people. The profits from that go into that smart contract as ether into its balance. If it needs repairing, it can send out a message and pay for a repairer to come out and repair it. And that's it. It effectively owns it's its own company. It owns its own money, it just does its own thing. So there's a lot of potential there for the IT side. Okay, I couldn't resist this, given given what's happened tonight. Okay, Hyperledger. So I don't know a great deal about Hyperledger, I have to say. It's a new thing, a new idea. A consortium has been built. IBM, Linux Foundation, some banks have got together to produce Hyperledger. I think the idea is that they are looking very much about the scalability side of things. They are focusing on how the blockchain is going to be used, particularly perhaps in the finance industry, where you'll be looking very much at very quick transactions. But they are still at quite an early stage. They're not as advanced as Ethereum. But what they come up with in terms of scalability will be interesting. And it's an issue that the community as a whole is going to have to look at. We do need to solve these problems. You finished taking your photo? Okay. So where are we going? On next steps. Okay, the first thing, and the one that people will often ask questions about. If you know a little bit about Bitcoin, how it works, it has a consensus protocol called proof of work. And you should all have heard of proof of work because of the company. I hope you've heard of it. At the moment, Ethereum uses the same mechanism for providing the consensus for the blockchain. It's a very simple means of arriving at a consensus. It's very straightforward. You do a very expensive computation, and it's effectively a race. Whichever person wins that race gets a reward. But it is computationally very expensive. The amount of electricity that's being used around the world to do this on the Bitcoin network, I've heard is as much as some small country uses. I've heard different countries, so maybe an urban myth about that, but it's a vast amount of electricity. From a green point of view, it would be better to move to something different. Ethereum wants to move to something called proof of stake. Unfortunately, this is much more complex. The final version of this hasn't been arrived at, I don't think. But it is going to come. The idea of this is going to be that people will effectively have a stake. They'll put up a stake in when they are doing mining, and if they prove to be a malicious person trying to subvert the network, then they will lose their stake, and that is how the network is protected from malicious people. That will come sometime soon. It will probably take a while for that to iron out all the faults. It is more complex than proof of work, but hopefully we will get there and we won't need to use so much electricity. One idea that's been proposed to get around some of the problems of performance, scalability, is the idea of sharding. So we write our applications on the Ethereum blockchain. At the moment, there is one blockchain. Every transaction, every application goes onto the same blockchain. There are about 1.5 million blocks at the moment, but every type of application that you write goes onto the same blockchain. There's the idea to make it to help scalability is that we would have a number of blockchains running simultaneously. And so, for example, financial applications may have their own blockchain, voting applications may have their blockchain, etc. And generally, the idea would be that these applications would generally send messages to applications on the same blockchain, but would rarely send applications to other blockchains. So that mechanism would be possible, but would be more expensive. Ring signature mixture is just a general account thing, the idea being that to help with anonymity and to allow things like multiple signature wallets and to allow people to send transactions to sign for things without it being too obvious who really did this. So if you're worried about sending some funds to wherever, for whatever you want to do, this is a way around it. Micropayments I've mentioned already. So yeah, DAOs, we're starting to see them. We will see a lot more of them, hopefully. Consensus applications, also governance. We're looking forward to seeing all of these things. This does depend to some extent on these next 2 points. Identity and reputation services. So at the moment, I like the idea that I can, say, do some transaction, buy something using Ethereum from somebody on the Ethereum network. But okay, I may know that account. I know I can be sure that's coming from a certain account, but I don't know who that is in the real world. It would be nice if I could know that. It would be nice for me to be able to say, this is who I am, this is my digital identity on the blockchain, and I could sign things and say that this is from me, and I can prove that my identity hasn't been stolen because only I have my private key. So we are waiting for people to come up with identity services for Ethereum. I think that will be a big step forward when that happens. At the moment, there is, if any of you, I don't know if any of you have tried applying for your e-residency for Estonia, but that is one way of doing this. You can apply to the Estonian government. You send them some documents. They send you back a card that allows you to set up businesses in Estonia, but you can get a reader that you can plug in and acts as a proof of identity. You can put that on the blockchain and prove your identity that way. Reputation services, this would be great. What I was saying earlier about hating agencies, recruitment agencies, contract agencies, I would love it if my reputation was on the blockchain. So if somebody wanted to employ me, they could look at the blockchain, they could look at my history and say, well, yes, we'd like to, but your last contract was rubbish, so we're not going to bother, or whatever. But at least it would be there, and they could see it easily, and they wouldn't have to go through an agency to do this. They could just see what my reputation is like. With that. Once we get those 2 things on the Ethereum network, and we get those starting to be used, I think then they'll help promote a lot of other applications and give people a lot of confidence in using Ethereum. So yeah, proof of stake I've already mentioned very briefly. The inventor of Ethereum, Vitalik, gave that quote about proof of stake, that effectively it's going to be a prediction market on the blockchain. So it's quite a complex thing. Looking forward to when it happens. That's it. Just a couple of. Unfortunately, I can't do the links. We don't have Wi-Fi. I run the Ethereum, the Ethereum meetup group. So if you're ever in that area, please check us out. For Java developers, the London Java community has a monthly hackathon called Hack the Tower. The next one is on June the 11th for people to go along and hack with Java. I, to some extent, hijack that slightly by running a blockchain project in there and looking at the Java client for Ethereum. So if you want to come along and try out any projects using Java and Ethereum, please do. I give introductions to Ethereum on that and the Java client. And that gives me time now for questions.